Okay, this is a scenario on experimental design and really talks about the components of an experimental design and why something is an experiment versus an observational study. So this is free response question 1999, question number 3. So the dentist in a dental clinic would like to determine if there's a difference between the number of new cavities in people who eat an apple a day and in people who eat less than an apple a week. They're going to conduct a study with 50 people in each group. So we have a group that eats an apple a day and those that eat less than 1 apple a week. So I'd like you to think about those that eat an apple a day, what type of person they might be, okay? I'm guessing they're fairly healthy. 50 clinic patients who report that they routinely eat an apple a day and 50 clinic patients who report they eat less than 1 apple a week will be identified. The dentist will examine the patients and their records to determine the number of new cavities the patients have had over the past 2 years. So looking at this, we have a couple things. Patients are reporting. That means they weren't assigned, they were already doing this. And the dentist is looking at historical records, okay? So once again, that's a couple things that are probably pretty key to us to determine the number of new cavities that patients have had over the past 2 years. They will then compare the results of new cavities in the 2 groups. So we do have 2 groups, which is good. So why is this an observational study and not an experiment? We have a few things going there. First off, no treatments were imposed or assigned. You're like, wait a second, I had people eating 1 apple a day and another eating less than an apple a week, but they self-selected, okay? If they self-select, the treatments were not assigned. So they were not assigned, they self-selected, and as such, that's not an experiment. Treatments have to be imposed or assigned, all right? And done so in a random manner. So another part, there was no random assignment. You're like, well, wait a second, aren't these the same thing? It's like, no. Here they were not, we didn't force them, we did not force a treatment on them. And not only that, the treatments were not randomly assigned. They chose it themselves, all right? So the random assignment and imposed. And finally, we used existing data. So we have 3 things here that, and we needed, and in order to get full credit, we had to have at least 2 of those. So and you could have said the treatments were not randomly assigned, okay? And but you need to make no treatments were randomly assigned would work. But you need to make sure you talk about the treatments not being imposed and the random assignment, and you need to say that they're using existing data. Part B, explain the concept of confounding in the context of the study. Include an example of a possible confounding variable. Well, remember, confounding means there's a variable that's impacting the study that we didn't control for, and so we don't know why we see what we see. I always recommend that you give the definition in your answer. So confounding occurs when effects of the variable cannot be distinguished from one another. That's my definition. Now, technically, that gets me no credit whatsoever. However, it gets me credit with the reader. What I'm telling you is, it's like, oh, this person knows something, and you're likely to get a little bit more lenient grading if your verbiage isn't perfect if you tell them you know the definition. The definition by itself gets you no credit, but it probably sets the reader up or the grader up for a positive attitude that you know something. So confounding means I don't know what's causing this. So what could be causing the decrease in cavities? Well, I'm sitting there thinking, if you eat an apple a day, you're probably pretty healthy. So you probably, and if you're healthy, you probably have fewer cavities. In this case, confounding would occur if it becomes impossible to measure the true effect of the number of cavities attributed group who eats more than 1 apple a week as compared to the number of cavities for a group that ate less than an apple a week. I have to put it in context. So now I've put it in context. Here's just the definition. Here's the context. Context alone, that's going to get me half credit. That's not going to get everything. Now I need to give the example, which is what they asked for. For instance, it's reasonable to assume that the group which consumes more than one apple a week has on average a healthier or consumes one apple a day, probably would have consumes an apple a day, has on average a healthy overall lifestyle, and that could be the cause for that group having fewer cavities when compared to the group that eats less than one apple a week. So basically, I put it in context of the study, and I gave an example of what can be confounding. In other words, you're overall healthier because, and why are you healthier? Maybe it's because you eat an apple. Maybe you just lead a healthier lifestyle. You're more disciplined. We really don't know, but you obviously take care of yourself. So maybe you brush your teeth and floss better than the person who doesn't. It really doesn't much matter, but I needed to have this. This will get me the other half. Okay. All right, part C. If the mean number or the average number of cavities for those who ate an apple a day was statistically significant, okay, so they're telling us this is statistically significant, there is a difference, then the average number of new cavities for those who ate less than one apple a week, could one conclude that the lower number of new cavities can be attributed to eating an apple a day? Explain. Careful. This is an observational study, so we can't make that conclusion. Because this is not an experiment, it's not reasonable to draw a cause and effect relationship between eating apples and lower number of cavities. So basically, I couldn't just say it's not an experiment. I have to put it in context as well. And the context here is eating apples and lowering the number of cavities. Now, it is statistically significant. So because it's statistically significant, we can say there's a relationship, there's a correlation, but we cannot say causation, right? And when I say attributed to eating an apple a day, what they're trying to say is, can you conclude that eating an apple a day will decrease the number of cavities? And the answer is no. Well, we can say there's definitely a relationship there, okay? Once again, must always be in context. Answers always have to be in context, 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 context. Okay? All right, so that includes that video.